Hello, welcome to Math with Mr. Dobrescu, to the rescue. Today we are going to work through 3 different activities to find some exponent rules. And we are going to use inductive reasoning to come up with some rules based on some activities. We are going to explore some exponents. So first we are going to find products of powers. And take a look at these exponents. We have 2 to the second power times 2 to the 4th power. What does it mean 2 to the second power? If we expand that, 2 to the second power means 2 times 2, like we've learned the other day. So 2 to the second power means 2 times 2. And then 2 to the 4th power, remember the exponent is telling us how many times we have to multiply the base. So 2 to the 4th power means 2 times 2 times 2 times 2, 4 times. So another 2 times 2 times 2 and times 2. And now if we take a look at all our 2's, so we have how many 2's? 1, 2, 3, 4, 5, 6. So now we have 6 products of 2's, right? So our final answer here as a power we have, so the base is 2, and then we raised to the 6th power. So the answer would be 2 to the 6th power. Let's take a look at the second example here. We have negative 3 to the second power times negative 3 to the 4th power. And again, negative 3 to the second power would mean negative 3 times negative 3. So we have negative 3 times negative 3. And then negative 3 to the 4th power would mean negative 3 times negative 3 times negative 3 and times negative 3. So another times negative 3 times negative 3 times negative 3 and times negative 3. And now let's see how many times we had to multiply negative 3. So let's count. 1, 2, 3, 4, 5, 6 times. So remember, the base is negative 3 because it is within a parenthesis. So the base is negative 3 inside of a parenthesis, and the exponent is 6 because we multiply negative 3 6 times. Okay, let's take a look at another one here. So we have 7 to the 3rd power, which means 7 times 7 times 7, 7 times 7 times 7, and then we have times 7 to the 2nd power, which means 7 times 7. 7 times 7. And again, we see that the base is 7, right? So here for the power, we have base is 7. And then we multiplied 7 5 times. So the exponent is 5. I want you guys to do 5.1 to the 1st power times 5.1 to the 6th power. You work on it. And then to do the other one. But let me work with you on the last problem there. 1 over 2 to the 5th power. So we have 1 over 2 times, again, 5 times 1 over 2 because the exponent is telling us to multiply 1 over 2 5 times. Times 1 over 2, times 1 over 2, times 1 over 2, and times 1 over 2. Okay, 5 times. And then we have to multiply it again another 5 times because we have another 1 over 2 to the power of 5. So again, 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2 and times 1 over 2. And now let's make sure we have 1 over 2 multiplied 10 times. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So again, in this case, the base is 1 over 2, right? So the base is 1 over 2, but the exponent is 10. And again, the other 3 problems here, I want you to try it and see if you can find the answer. I want you to do the expanded form first, and then write it in a power form. Okay? So take about a few minutes, work on those problems, see if you can find a pattern, and if we can answer this problem here in general form. A to the m times a to the n would be what? Okay, so we are going to use inductive reasoning. So the inductive reasoning is telling us that through exploring these patterns here and coming to an answer here, what did we do here from to the exponents 2 and 4? So obviously we added the exponents. You see 2 plus 4 becomes 6. The same here, 2 plus 4 becomes 6. We kept the base, but we added the exponents. So if we have the same base, and if we multiply another base, but we have different exponents, we keep the base and add the exponents. So using the inductive reasoning, in general terms, if we have a to the m times a to the n, the answer would be, we keep the base is a, right? So we keep the base and add the exponents. That would be m plus n. M plus n. Let's take a look at activity 2 now. So activity 2 is telling us, now we need to write a rule for powers of powers. So we see here, 3 to the second power, all to the third power in a parenthesis. So our base is 3 to the second power first. So now this is telling us that the exponent, the power, is telling us that we need to multiply 3 to the second power 3 times. So we have 3 to the second power times 3 to the second power and times 3 to the second power 3 times. And now if we break it further down, 3 to the second power would mean 3 times 3. So we have 3 times 3. 3 to the second power means again 3 times 3. And 3 to the second power means again 3 times 3. And now if we count all the 3's, we see that we have 6 3's. We multiply 3 6 times. So the base is, in this case here, the base is 3 and the exponent would be 6. Base is 3 and the exponent would be 6. Okay? Let's take a look at the second example and then we'll see if we come up with the rule. Second example, we have 2 to the second power all raised to the fourth power. In this case, we see that the 4 is telling us that we need to multiply 2 to the second power 4 times. Times 2 to the second power, times 2 to the second power, and times 2 to the second power. And now if we break it further, 2 to the second power means 2 times 2. So we have 2 times 2, and again times 2 times 2, and again times 2 times 2, and one more times 2 times 2. And now let's count all the 2's in our sequence here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 factors of 2's, right? 8 2's multiplied together. The base is 2 and the exponent is 8. So the answer would be 2 to the power of 8. And let's take a look. I want you to do C and I want you to do E, and I'm going to do D with you guys now. So we have y to the third power all to the third power. So this exponent here is telling us that we need to multiply y to the third power 3 times. Okay? And now let's break it further. Y to the third power means y times y times y. So we have y times y times y, and again y times y times y, and one more time because we have another y to the third power, y times y and times y. And now let's count all the y's here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 y's, but the base would be y, and the exponent would be 9. So our answer would be y to the 9th power. And now let's come back here to the initial examples, and let's see if we can find a rule for this so we don't have to do all this hard work. So take a look here. When we have a number, a base raised to a power and then raised to another power, What did we do to exponents here to come to the 6? Did we add or did we multiply? We multiplied, right? Because 2 times 3 becomes 6. The same here. 2 times 4 becomes 8. And the same here, 3 times 3 becomes 9. So in general terms, to come up with a rule, if we have a to the power of n, all to the power of n, the final answer would be the base is a, and in this case we are multiplying the exponents to the power of m times n. So a to the power of n times n, and again we used inductive reasoning to come up with that rule. And let's take a look at our last activity here, activity 3. Now we are going to write a rule for powers of powers, right? So here we have 2 times 3 in a parenthesis to the power of 3. And this 3 again is telling us that we need to multiply 2 times 3 3 times. So let's multiply. 2 times 3 times 2 times 3 and then times 2 times 3. 3 times. And now we are going to do the same thing. Let's see how many 2's we have here. So we have 1, 2, another 2, and another 2, right? So we have 3 2's, but the base is 2. So the base is 2. So we have 2 to the 3rd power times, and let's see how many 3's we have there. 1, 2, 3. So times 3, the same thing to the 3rd power. And that will be our answer. Okay, let's take a look at example B now. In this case, we have 2 times 5 to the 2nd power. So the same thing, we have to multiply 2 times 5 twice. 2 times 5 times 2 times 5. Okay. And again, let's count how many 2's. So we have 2 2's. So the base is 2 to the 2nd power because we have 2 of them. And then times 5 to the 2nd power. Okay? And now I want you guys to work on C and D. And let me work with you on E. The same thing here. For E is telling us that we have to multiply 3x twice, right? So we have 3x times 3x, right? 3x times 3x. And again, we have 2 3's, so it's going to be 3 to the 2nd power times x to the 2nd power. So again, take a few minutes, work on C and D, and see if you can use inductive reasoning, and then see if we can find a rule in general terms. Okay? Take some time, work on those problems, see what you get, and see if we can find a rule. And again, after you've been working for a few minutes, you will discover that anytime we have a base times another base, all raised to an exponent, the rule would be each base has to be raised to that exponent. Okay? Each base has to be raised to that exponent. You see that? 2 to the 3rd power times 3 to the 3rd power. The same here. It's going to be 2 to the 2nd power times 5 to the 2nd power. The base stays the same, raised to that exponent, times the 2nd base raised to the same exponent. So in general terms, we can say that if we have a times b to the power of m, we need to raise the first base, a to the power of m, times the 2nd base, also to the power of m. And that's going to be our answer. A to the m times b to the m. I hope these explorations and these activities gave you a little insight of how to use inductive reasoning to come up with exponent rules. And thank you so much. I appreciate you taking the time to watch this video. And please Stay tuned for the next video. And again, don't forget to like and subscribe and hit that notification bell so you'll be notified when I'm going to post more videos. All the best to you.